Okay, picking up at number 18. Beverly's going downtown to the movies at the River Center Mall. The parking garage charges $3.50 for the first half hour. And then it's going to be 75 cents per hour. So notice they've got 75 cents. Here you'll notice they're charging 75 cents per hour, but they're going to subtract out that first half hour that you've already paid $3.50 for. Okay, so that's what all that stuff is talking about. Which of the following statements best describes the function? Every hour costs 75 cents regardless of how long they park. Well, that's not true. If they only park for half an hour, it does not cost 75 cents. So that would not be a true statement. The first half hour costs 75 cents. I agree. And the remaining time, oh no, I totally don't agree. No, the first half hour costs $3.50. If they park longer than 30 minutes, they pay 75 cents per hour. Well, this is kind of true, isn't it? But it doesn't say anything about that $3.50. If they park longer than 30 minutes, they pay 75 cents per hour plus the $3.50. So D is actually going to be your answer. And that's just because C is incomplete. Pick the graph that matches this scenario. He walked up the hill and then down a hill, and it's speed versus time. So if it's speed versus time, that means these are going to be time. And this is the y will be speed, right? Okay, so thinking about just what that would look like. If I'm going, as time goes by, if I walk up a hill, am I going to go faster or slower than when I walk down the hill? So maybe you're thinking going up the hill, you know, I'm walking up the hill, here's my speed. And then when I start going down the hill, wouldn't I increase my speed? Okay? Maybe that would be the way that would go. So that would be my idea to kind of walk through. And you could go through each one of these. If you'll notice, this looks like, this is going up and down, but it has nothing to do with going uphill and downhill. This is actually my speed is increasing while I'm walking up the hill, and my speed is decreasing when I walk down the hill. That doesn't even make sense. If I'm walking downhill, I'll probably be going a little bit faster. This one talks about, I just, start off going some speed. Going up the hill, I slow down, I come to a stop, and then I go up a hill, and there's nothing really that talks about going to a stop or anything like that. This one looks like, okay, I start walking up a hill, and this is my speed, and then I reach going downhill and my speed increases. So this is the one I'd lean toward going with. This one's talking about I'm walking up a hill and I'm getting faster and faster, and then I'm walking down a hill and, I flatten out. I don't really agree with that one either. This one's talking about I slow down as I'm going up a hill, which I'm kind of okay with that. I'm curious how I started off at that speed and I didn't have to increase to it. But then here, when I'm going down a hill, I'm going to keep the consistent speed. Don't you go a little faster when you go downhill? So I would tend to go with C on that. We get to graph some systems of inequalities. So let's see how this looks. If I use the hand, that means this wouldn't be there, right? So I'd have 2x equals 6, so x equals 3. So that would be my x-intercept. Then if I go back and I use the hand again to get my y-intercept, then that would mean my x is now 0, so I got negative 3y equals 6, so y is going to equal negative 2. So now I have this. So then we have to decide, is this solid or dashed? Well, you'll notice there's no equal sign underneath that inequality, so this should be dashed. Then let's go ahead and pick another color. I got a y-intercept of 3, so 1, 2, 3. We got a slope then of negative 3/4, so down 3 over 1, 2, 3, 4. I got 2 points. Because there's that line under there, that means I need to draw a solid line. So there's my line. In both these cases, we got to figure out where to shade. So since I skipped the purple one, I'll go back to that in a minute. This says y is greater than, so we'll put our pencil in the line. We'll use a little common sense. Y is greater than. Doesn't that sound like up? Would it be up or down? That same old question I keep asking y'all. Up. Isn't that where the y's are bigger? The other one, we're going to have to plug in a point. And we always plug in 0, 0 as long as it does not go through 0, 0. That's the only time we get into a little trouble. And the reason is because, once again, we're trying to find out if 0, 0 is a solution, because if so, it should be in the shaded area. Well, this says 0 is greater than 6, which is a false statement, which means this is not a solution. So this point right here should not be in the shaded region, which means instead we should shade the other way. So now that you have both of your inequalities graphed, you're looking for where do the two overlap. And that's going to be right over here in this corner. Then let's see, they got this multiple choice question. Which of the below is the solution? 6, 2. Let's see. 1, 2, 3, 4, 5, 6, 1, 2. Well, if anything, that would be on the dashed line. And if it's on the dashed line, it's not a solution. Negative 1, 10. Negative 1, 1, 2, 3, 4. Is there any way anything up here is going to be a solution? No. 7, 1. 1, 2, 3, 4, 5, 6, 7. 1 is right there. Yes, this is a solution. Once again, doing multiple choice, we always do them all. 1 and negative 8 is going to be down here somewhere. So no, it's not a solution. And we got our answer. Oh, we're done with that page. Next, use the table to write the following equations. We kind of already did this a little bit. This would be bird beaks, negative 1. This would be positive 2. This would be negative 4. This would be 8. So if you'll notice, I'm getting a slope of negative 1/2. So I've got y equals negative 1/2. Remember, HK form looks like slope, x minus h, plus k. Where hk can be any one of these points, I'll just go with the point negative 4, 3, just because it's at the top. So I do x, insiders lie, since it's negative 4, I'll put positive 4, and then outsiders are the good guys, so plus 3. Converted to slope-intercept form. I need a little workspace here. I'm just going to do it off to the right. I'll do it in red so it looks a little different. I got negative 1/2 x. I got half of 4 is 2, so I got negative 2. And then I got that plus 3 out there. So our slope-intercept form would be negative 1/2 plus x plus 1. Converting it to standard form, step number 1 would be to add the half x. And then once again, remember we can't have any fractions, so we got to multiply this by 2. When I do, I get x plus 2y plus equals 2. And that would be our standard form. Okay, and we just did a little bit of that a while ago. Circle if this is continuous or discrete. Okay, so if it's continuous, I can trace this without picking up my pencil. Yay, I can, so it's continuous. You always have to do that if you're going to decide what type of domain and range you're going to do. If it's continuous, we're going to do the less than x, less than y, less than. To do the domain, I want to go left, less than x, less than right. To do the range, I want to do bottom, less than y, less than top, okay? So the very far left of my graph is right here, which would be 1, 2, 3, 4, negative 5. It's an open circle, so there is no equal to. That's just like having that dashed line. My very far to the right is right here, which is 1, 2, 3, 4, 5, 6. So this is 6. Notice you got a closed circle, so that will be equal to. My range is going to be bottom. So this is the bottom of my graph right here, which would be 1, 2, 3, 4, 5, negative 6. Once again, open circle, so there is no equal sign. This would be the top. I'm not really sure where this is supposed to be. Let's say it's right here, okay? Because I'm not sure where it should hit pretty We're going to let it hit pretty. 1, 2, 3, 4, 5, 6, 7. What does that look like on y'all's? Kind of looks like it's in between. If you wanted to, we just put 7.5. How about that? Okay? Is this a function, yes or no? What you're interested in when I ask you if it's a function or not, I'm going to erase this stuff so you can see. Function, yes or no? You want to do the vertical line test. So when I draw vertical lines, will I touch this graph twice in any place? And the answer is no. You don't have to draw all those lines. You could just run your pencil across. For example, when I come over here, whoops, my thing's a little off. You'll notice this right here does not pass the vertical line test. That one's not a function. This one is, okay? Over here, by the way, continuous or discrete, I have to pick up my pencil. I don't get to connect these dots. So this is discrete. Your points are always going to be discrete. This one, once again, function, yes or no. I won't touch any of this graph twice. So yes, it's a function because it passes the vertical line test. Is it increasing or decreasing? Well, as I go from left to right, am I going up or down? If I'm going up, that would be increasing. If I were going down, that would be decreasing. This one right here, function, yes or no? This 0 repeats, which means it's not a function. Okay? And that's what you're looking for in a mapping. If I have to do the domain, you'll notice it's just data, so I'm going to do discrete. And it would be -1, 0, 5. All I'm doing is listing my input. Then for my range, I would do 3, 5, 7. Remember, when you write a set like this, it should be in order from least to greatest. And of course, we use the discrete domain and range, which is going to match the fact that we say it is discrete. Make sure those always agree. It's always interesting when y'all put it's discrete and then you use a continuous domain and range. Okay, so it says, describe g of x as a transformation of f of x. Okay, so g of x is going to be the new graph, and it's going to be this transformation right here. So before I even look at all that stuff, I'm going to talk about what this is. The 1 is an insider. Since it's an insider with the x's, that means it's going to impact the x's, which means it's going to impact your graph left or right, because it's adding. If you're adding or subtracting, it impacts your graph left to right. So in this particular case, insiders always lie. So it is saying typically if it says x plus 1, it actually means x minus 1. If it says plus 1, you think it'd move to the right, but since insiders lie, it is actually going to move the left 1. And hopefully that kind of, you remember that from Moves a Monster. If not, I know that Moves a Monster is still in Google Classroom. Then, since this is an outsider, that means it's going to impact your y's. Your y's are going to be up and down. So since this is plus or minus, it's going to shift your graph either up or down. -4, outsider's a good guy, so it's actually going to move your graph down 4. So when you go over here, you talk about f of x was translated left 1 and up 4. Nope, it wasn't. Right 1, nope, it wasn't. Left 1 and down 4. There you go. Right 1, nope, it wasn't. Remember, always eliminate the other. Jones Bank offers interest on deposits. The equation looks like this. The annual principal 1 plus the rate represents the amount of money, A, in the account 1 year after depositing the principal at an interest of rate R. Which of the following equations does not represent the equation solved for the interest rate? Well, remember, the interest rate is R, so we need to get R by itself. To do that, the first thing we're going to do is divide both sides by P. That's going to give me A over P equals 1 plus R. Then all we have to do is subtract 1 from both sides. So I end up with A over P minus R. So if you look up here, you'll see A over P. I didn't say A over P minus R. I meant A over P minus 1 equals R. Okay? If you look, it says does not. Hold on. Does not. And here's what they're showing you. Ooh, that would have been a boo-boo. This one does, right? So that's not an answer. Well, then if we got this as a, we could have also done it this way. A common denominator. A And then if I want to find the common denominator for this side, I do p times -1, so I get a minus p. Notice this right here equals -1. So I have a minus p over p, which would be this one right here. And then if you look at this last one right here, isn't that the same thing as AP minus 1? So this one right here, oops, I'm supposed to line that off. This one also does not. This is our scenario right here. We didn't end up with P underneath the 1, so that would be your final for that one. And that you just need to slow your road on that one. Make sure you're paying attention to it. I think we're on to the next page, right? So I'm going to shut this one down and start another.